is tan x. So it's a half tan x. So it's actually tan x over 2. What does this give us? This implies multiplying across by 2. This implies that sine x is less than x, which is less than tan x. Defining tan x in terms of sines and coses, this implies that sine x is less than x is less than sine x over cos x. Dividing across by sine x, okay, well then this implies that, well, sine x over sine x is less than x over sine x, which is less than, well, this is going to be divided by sine x, which just leaves us with 1 over cos x, okay? Maybe I'll just put a little box around this stuff here, that this was really just, this was sort of just rough work for us, okay? Let's just leave the box around here. We're not interested in x over sine x, sure or not? No, we're not interested in x over sine x. We're interested in sine x over x. So if we flip these particular fractions, right, just keep in mind, let me just cross this over here. Okay, let's just keep in mind what we have. Okay. Just keep in mind if we have something like, let's say, if a fraction is less than another fraction, well, let's write down two fractions that are less than each other. Let's say we have 3 over 4 is definitely less than, it's definitely less than 3 over 2. Okay. Now let's flip them. You can clearly see that 4 over 3, and when we flip this, we get 2 over 3. Well, 4 over 3 is now bigger than 2 over 3. So just keep that in mind. So that what we can actually do now is that we can flip across. So don't forget, sine x over sine x is just 1. So this implies that 1, well, let's just write it out as is. 1 is less than x over sine x, which is less than 1 over cos x. And now if we invert, this implies that, well, 1 over 1, when we invert, is just 1 over 1. 1 must be greater than sine x over x, which must be greater than cos x. Okay, so interesting. So now let's actually just get some limits across this. Okay, so this implies, well, then what we have is we have that the limit of 1 as x tends to 0 must be greater than the limit of sine x over x as x tends to 0, which must be greater than the limit of cos x as x tends to 0. Well, you can see that this is just a constant function here. Okay, irrespective of what's happening with the angle, this is always going to go to 1. So this implies that 1 is greater than the limit of sine x over x as x tends to 0, which is greater than, well, the limit of cos x. Well, cos x as x tends to 0. Well, x is getting closer and closer to 0 in radians. So cos x is going closer and closer to 1. So actually, this is greater than 1. So effectively, what we've actually just shown is that the limit of sine x over x is less than 1 and greater than 1. So what we've effectively done is we've actually bounded it here. So therefore what we have is that the limit of sine x over x as x tends to 0 must be equal to 1 as required. There's probably one just thing to keep an eye on is in relation to x going to 0 here. If it's going from the positive direction, we don't have any problems here. If it's coming in from the negative direction, just to keep in mind that we do have, if x is negative, that we do have sine minus x. Let's say if it's negative over minus x, well, we know that this is an odd function. So this is actually the same as minus sine of x over minus x, which is the same as sine of x over x. So irrespective of the directionality of where the limit is coming in from, okay, we're still going to be perfectly fine here. But effectively, what we've done here is we've just shown, where did I throw that page? Here it is here. Okay, we've just shown that the limit of sine x over x is equal to 1 as x tends, the limit of sine x over x as x tends to 0 is equal to 1. Which we're just saying is just keep an eye on this limit because it's a very, very important limit for us, and it's going to pop up so many times in future derivations that we're going to do. Okay, guys, once again, this is Jonathan Lambert with Maths and Stats, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful to you, and thanks for watching. Okay, bye-bye.